Hello, welcome to Baron Automation. So today we're going to be talking about the Siemens 300 PLC. So this PLC is actually a CPU 3152DP CPU 3152DP PLC. So today we are going to be looking at the different modules that this PLC work with. We're also going to be looking at how it controls the various IOs. So these are the IOs, the push buttons, um, normally open and normally close push buttons. We have some selector switches here. Then we have some LED indicators here that the PLC work with. So on this trainer board, this board is actually for training. For training only. So here I have an MCB, which is an inverse current circuit breaker, where the incoming power cord comes into before it's being converted to before it's being sent through the terminal blocks. So we have various terminal blocks here that actually connects the AC or sends AC signals over to the different push buttons and LEDs where they are being used. So from here, just beside the CPU, I have the power supply unit here. This power supply unit here converts AC that's coming from down below to DC and powers the PLC and also the signal modules, which are the digital input and digital output modules. So I have no analog modules here. All these are digital input and output modules. The PLC itself is the brain of the entire system, of the entire control systems. So here we have on this PLC, there are so many things that could be seen on the PLC. I'm going to be focusing more on the PLC here. Here is a CPU 3152DP, which means it's an S7300 PLC. 2DP means it has two ports, so you can see the two ports here. The first one here and the second one is this over here. So this second port can enable it to do two communications simultaneously, which is the MPI, that's a multi-point interface, and the second one, which is the DP, which is the decentralized peripheral. So it enables it to do two communications at the same time. So on this PLC, I could have different voltage swings here, where I can switch from 230 volts or 120 volts based on the voltage types I'm using. Okay. So on here I see LM, which is live and neutral outputs for the DC, as DC is always polarized, as well as AC, but it's more pronounced in DC. This is polarized. So back to the PLC, we see different indicators. So I'm going to power it on now, and you see just how this thing operates. Okay, so right now I switched on the power, and I see the indicator lights. So the PLC now, when you switch it on, you see this at first, then followed by this blink, which means it's booting and it's ready to operate. So you can see that the program that I wrote here is already started to operate. The program is already operating, and that blink is also shown by this indicator. So here my PLC is actually currently on run P, so I can set this toggle switch to run, which sets the system in run. So the difference between run P and run is that while I'm on run P, it means run program, and I can reprogram the PLC at that particular moment. So here now it is run. I can also set it to pause, to stop, sorry. When I put it on stop, my program stopped running. I can see that the LEDs are stopped blinking, and I can also do memory resets. So I'm not going to be doing any memory resets for this video. I'll just carry on with my training. So you can subscribe and watch subsequent program on how to do memory resets on this. Okay, so now I'll go back to run. I've already told you the difference between run P and run. So now when I'm on run, you can see the different thing that this program is doing. So when I press start push button, you can see there will be something happening in the indicator. So I press start, so I see the 3 LED comes on. This is based on the program I've written in this PLC, and everything is going off at simultaneously. So next, I'm going to press stop. See what happened there. Okay, nothing happens. Let me press start again. So before those code goes, I'll press stop. Okay, nothing happens. Let me press start on this. Okay, so this actually stops the blinking of that. Pressing start again, and let me see this. Okay, so basically how this program runs is that while I turn on the PLC, this guy blinks and tells me that my system is on, and that's just going to be done for a certain time. But when I press this LED comes on, and they go down, they go off by themselves one after the other. Okay, so let me set the PLC in stop mode again. Now it's in stop. You can see the stop indication here. When I set it on start, my first LED start blinking, which shows that the system is just on. So this is just a very simple program, and in subsequent videos I will show you the code I've written. So this PG is there to program the PLC, so I can use this. It's called the programmable device, or the MPI cable. You can call this the MPI cable. So it's just to connect to the programmable device, that's the PG, or your computer. So this is the code here. It has an MPI and a USB port. So I connect it through here to my computer. So this is a USB port, and the other end is an MPI port. The other end is an MPI port. So now it's not actually being connected, so the indicators are presently off. Okay. So back to the PLC, I can my code is actually saved on this memory card. This is the memory card for the PLC, and these are the I/O terminals as I explained earlier on. Okay, so thank you for watching the video. Like and subscribe for more interesting videos on boron automation. God bless you.